Okay, this is our review of graphing linears, part one. The first form of a linear that I want to look at is this one that's up here in orange. It looks almost identical to the absolute values we were just doing in the last video if you just watched that. If not, I would go back and watch that one first before watching this one. The only difference is instead of absolute value bars, we now have parentheses in the place of the absolute value bars. So with the absolute value, it was called standard form. So this is standard form, right? That would make sense, huh? Yeah, no, it's not, because math, sometimes we're just not nice. We actually call this point form. And the reason why is in an absolute value in standard form, we were always asking, what's the function's turning point? Well, it's a line, so it doesn't turn. It always goes up or it always goes down. So it doesn't have a turning point, but it does still have a regular point when we look at that equation. We are still going to be looking at our h and our k, and our regular point is still going to be opposite of h, comma, k. So it's just a little bit different. Also with our absolute values, we had looked at, does the graph open up or open down? And we had looked at the a value for that. We're not really going to ask open up or open down anymore. We're going to ask, does the graph rise or fall? And it's still going to be the a value that's going to tell us that. If the a value is positive, our graph is going to be rising through whatever point we came up with. If the a value is negative, our graph is going to be falling through whatever point we came up with from our equation. And then the way it rises and the way it falls, again, is specifically the a value. And remember, that's going to tell us our rise over run, kind of like we were doing in the last one with our absolute values. So again, if you have not gone back and watched that absolute value, you might want to do that one first, just as a frame of reference. Okay, so let's do a couple of examples. So in this first one, this is a linear because of the parentheses and not the absolute value bars. It's still going to be telling me a point, though. Opposite of the h, so a positive 3, and keep the k value the same. So I'll go ahead and plot that, 3, 4. Okay, so now this is not a v. We're going to make a line through this. We just need to decide, are we going to be rising through our point or falling through our point? And our a value is going to tell us that. So since it's a positive 2, we know we're going to be rising through our point, and we know that we're going to rise to, so up to right 1. Always going to the right. It helps us out. We either rise to the right or fall to the right. So we are rising to the right, 2 over 1, 2 over 1, 2 over 1. So I will be rising just to kind of fill up my graph a little bit more. Actually, I'm going to make that first point a different color just so we remember that's where we started. But we could fill in our line in the opposite direction. Also, if we wanted to, again, if you're being a great student, you put all the points that fit on your graph. Okay, so starting point and then our rate of change. One more example. So here, it looks as if one of the pieces is missing. So just like we did in that absolute value video, I'm going to rewrite this. And the piece that is missing is the k at the end, and we talked about in the last video, when it's missing, it's because you must have added 0, which doesn't change it. That's why people don't show it. But, all right, so our turning point is still coming from our h and our k. So I need to change the sign on my h, make it a positive 4, comma 0. Plot that over 4 up 0. There's my start point. And then we need to decide, are we rising through our start point or are we falling through our start point? And that is coming from our a value. Since it's negative, we know we are falling. And we're going to fall 1 and go to the right 3. So down 1, out 3. Always going to the right so that I'm either rising or falling to the right. And then you can fill in the opposite direction. And if you're an awesome student, you will fill in all of the points. And I know you all are awesome students, so you will do that. Okay, so there is our line. And just to double check, as I read it, it is falling to the right, which is what my slope told me to do. Okay, so that is point form. Now what about this one? In this one, This actually may be looking really familiar to you. It's maybe your excited face of, oh wait, I know this one, I know this one. That's y equals mx plus b, that's slope-intercept form. For some reason in Algebra 1, a lot of times we overemphasize this form and people get really excited because this is the one they know. But let's see if I can just blow your mind just a little bit. This is actually point form, the same form we've just been doing. It's just missing the parentheses. So if I rewrite it with the parentheses, remember x is always inside the parentheses, what number would have been in the parentheses that would have had no point of showing, and that's why they didn't show it. And we've already talked about that. When that number is not shown, it's a 0. And that number out there is still a -1. So really, we don't really need slope-intercept form. It's really point form in disguise. So yes, feel free to be excited, but point form in disguise. So it's telling us that our first point is, switch colors, first point is 0. Even if you change the sign on 0, it's still 0. -1. And 0, -1 is on the y-axis. This is why this one's called slope-intercept form, because it tells you your y-intercept as your start point. So it's not just a random start point, it's kind of an important start point. And then we need to decide, is our line rising or falling through that point? And again, we're looking at our a value for that. Since it is positive, we know that we are going to be rising 5 and going to the right 2. So up 5, out. Wait, 1, 2, 3, 4, 5. Counting skills are not on par today. Oop, that was out 3. Oh man. Redo. Up 1, 2, 3, 4, 5. Out. 1, 2, 3, 4, 5. Out 2. Oh my goodness. All right. Up 5 again would put me at 9. Out 2. There we go. And then I could go backwards. Down 5. Out 2. And again, you would fill up your whole graph with any points that would fit. So slope-intercept form is really just point form in disguise. It's just that the parentheses are missing, so there must have been a +0 inside of the parentheses. So here's another one. Again, you can think of this as slope-intercept form if you want, but let's just make life simple, in my opinion, and only think point form. So if you're thinking point form, we're missing our parentheses and we're missing a number at the end. So this is what I've got so far, but I'm missing what numbers in the parentheses and I'm missing what numbers at the end. So of course, those would be zeros. So where is this telling me that my start point is? 0, 0. Which hopefully you haven't forgotten is called the origin. And then are we going to be rising or falling through the origin? Since that's negative, we will be falling 4 and then going to the right. What number is on the bottom of that fraction? If you make it into a fraction, it would be a 1. So falling 4, right 1, falling 4, right 1. And again, you could extend backwards. If you're a good kid, you'd fill in your whole graph with as many points as would fit. Okay, so that is point form, and then slope-intercept form, which is really just point form in disguise.